KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, here in this class, we are going to discuss about refraction and reflection of plane waves using Huygens principle. In that, first we will focus on refraction of a plane wave. Refraction of a plane wave, right? In our last class, we discussed what is Huygens principle and what is the use of Huygens principle. Okay, so we can find the shape of a wave. You can find the shape of a wave at any given instant of time. If at any given instant of time is possible by using Huygens principle. At the same time, we also can say one more point, that is, on a wave front, whatever it may be, but each and every particle on a wave front acts as a source of secondary wave. Source of secondary wave. So how it happens, how it is possible to see, that and all we discussed in our last class. Okay ma? Right. So now we will focus on refraction of a plane wave. Refraction of a plane wave. Okay? Right. So if you concentrate here, what is refraction we know. What is refraction we know. Right? So bending of light ray at the point of separation of both the medium, when it propagates from one medium to another medium, from one optical medium to another optical medium, right? So refraction is the name of the phenomena which is or in which a light ray bends at the point of separation of both the media when it enters from one optical medium to another optical medium. Okay, right. But here our discussion, refraction, we are in a discussion according to Huygens wave theory. So we are assuming that and we are believing that here. So by assuming, by believing and by following also, light is propagating from one point to another point in the form of wave. So in that context, we are going to discuss refraction again. Okay, see here. See this picture, ma. First you try to understand the picture. It is very important for us. Okay, see this. It is the point. That is what a surface which separates both the media. Right? So it is which separates. See the light, ma. Which separates both the medium. So it is medium 1. It is medium 1. It is medium 2. It is medium 2. Okay, right. So it is the incident wave front. And this is the normal. Which is the normal. You know very well, when it enters from one medium to another medium, it bends. So whether it bends towards the normal, whether it bends away from the normal, that consequences we discussed in our previous chapter, ray optics. Okay. So it is the line drawn from here to, from A to B. Right? So here also this is the refracted ray, in the form of wave. it is a phenomenon, I mean it is the resultant of refraction, it is EC. So letters also important, it is A, it is B, it is C, it is E. Okay. So afterwards it is A dash, and it is incident wavefront, and it is angle of incidence, right. So it is also angle of incidence according to geometrical mathematics. When it is angle of incidence, this is also angle of incidence, and then it is angle of refraction. When it is angle of refraction according to geometrical mathematics, this is also small r, right. It is the incident wavefront, but it is refracted wavefront. Okay. So obviously or generally we can write V2 is less than V1. Based on this, you can say V2 is less than V1. V2 is the speed of light in second medium, and V1 is the speed of light in first medium. Okay, right. And moreover, if you see, this is the if you see that geometrical mathematics here, if V1 is the speed, V1 into T is the distance. It is the distance travelled from here to from B to C. Okay. Next, it is the distance, right? It is from V2 into tau, right? If V2 is the speed and tau is the time, V2 into tau is the distance from here to there. Okay. So that is the one thing, and it is one thing and it is other thing, because here V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. Okay. So it is the distance and it is also distance, but it is in one medium and it is in another medium. Okay. And I already told you it is the refracted wavefront, it is the incident wavefront. Okay. So this is all about the picture. This picture shows us refraction of a plane wave. The same topic, refraction, we already discussed in the chapter of ray optics, but there light travels in the form of straight line. There light is propagating from one point to another point in the form of ray, but here light is propagating in the form of wave. Okay, that is the difference between there and here, but phenomena is same. That is what refraction, just a bending of light ray at the point of separation of both the media when it enters from one optical medium to other optical medium. Right. See here, let P dash represent the surface separating medium 1 and medium 2, right. So it is P dash, here it should be P, it is P and it is P dash. You just imagine here a letter P. So P dash is the surface which separates both the medium 1 and medium 2. Next, let V1, V2 represent the speed of light in medium 1 and medium 2 respectively. We assume a plane wavefront. AB, right? This is the AB. AB propagating in the direction of A dash A. So it is coming from there to here, that is, right. So in our previous class, I showed you what is a spherical wavefront and what is a plane wavefront, right. That is, so that we are here we have to imagine a plane wavefront. We assume a plane wavefront AB propagating in the direction A dash A, incident on the surface at an angle I. This is the angle of incidence. So obviously angle of incidence is the angle between normal and direction of incident wavefront. Here direction of incident wavefront. Next, let tau be the time taken. By the wavefront to travel the distance BC. So observe carefully, So what is the time tau? So it is the time for the wavefront to move through the distance BC. So that is the reason here you just understand why I am writing V1 into tau? V1 is the speed, no? Tau is the time. Then what you will get if you multiply? Speed is equal to distance by time. Distance is equal to speed into time. So here BC is the distance we are getting with the just multiplying with the speed and time taken to travel the distance BC. Okay, right. So here this picture and this information explaining us or showing us how the wavefront is coming, where it is going to incident, what is the angle of incidence, and how it is going to refract, what is the angle of refraction, with measurements also. Measurements means just what is the length of the ray and what is the how much time it will take, etc. Okay. So that and also I will explain you either in the picture or in the matter. Okay, right. See the continuation here. In order to determine the shape of the refracted wavefront, we draw a sphere of radius V2 into tau from the point A in the second medium. Listen carefully, ma. In order to determine the shape of the refracted wavefront, we draw a sphere of radius V2 into tau from the point A in the second medium. You just imagine the picture. Full stop. Let CE represent a tangent plane drawn from the point C onto the sphere, right? Full stop. Then AE is equal to V2 into tau. So how BC is equal to V1 into tau? Similarly, AE is equal to V2 into tau. Okay, and CE would represent the refracted wavefront. Okay, right. Now see this. There are two triangles, ABC and AEC. You know that sin theta is equal to opposite side by hypotenuse, right? So from this formula, based on this, sin I is equal to BC by AC. Sin I is equal to BC by AC. BC is equal to V1 into tau, no? V1 into tau, right? So V1 into tau by AC. BC is equal to V1 into tau by AC. Okay, right. Afterwards, and similarly that, okay, in a similar manner, sin R is equal to AE by AC. Okay, sin R is equal to AE by AC. That is equal to same formula, sin theta is equal to opposite side by hypotenuse, no? That we are applying for the triangle AEC. Then we can write it as sin R is equal to AE by AC. That is equal to V2 into tau by AC. So you just imagine this is as equation number 1, ma, and this is as equation number 2. This is equation number 1 and this is equation number 2. Okay. So mathematically from these two equations 1 and equations 2, you just divide like 1 by 2. Then what will happen? Sin I by sin R is equal to V1 by V2, because AC will get cancelled, tau also will get cancelled, right? V1 by V2 will come. Sin I by sin R is equal to V1 by V2. So it is like equation number 3. Here I is the angle of incidence and R is the angle of refraction and V1 is the speed of light in medium 1 and V2 is the speed of light in second medium. But okay, those are the terms explanation I told you. But what I am asking you is to observe this equation carefully. Okay, right. Suppose if R is less than I, if r is less than I. Generally r is less than I means what? The ray bends towards the normal. Ray bends towards the normal. Okay. The speed of light wave in the second medium will be less than the speed of the light wave in the first medium. So be in order, what I am saying. First what I told, you just observe this equation. Right. Now what I am saying is, if, just assume, if r is less than I, then what does it mean? The ray bends towards the normal. When the ray bends towards the normal, when the speed of the light wave in the second medium will be less than the speed of light wave in the first medium. Right. So this prediction is opposite to the prediction from the corpuscular model of light, as we discussed in the first class. Wave optics first class, I told you the prediction from Newton's corpuscular model of light, and then I also told you prediction from wave theory of light. Now I request you, you just please compare this one, this idea with the corpuscular model of light. Then this prediction is the correct one, right? So what is the correct one? When r is less than I, ray bends towards the normal. Ray bends towards the normal. When ray bends towards the normal, you can say that speed of light wave in the second medium will be less than the speed of light wave in the first medium, right? So this prediction is from Huygens wave theory. This prediction is opposite to the prediction given by corpuscular model of light, so that you can say that prediction of wave theory is correct. Prediction of wave theory is correct. Okay, right. Now next step. If c is the speed of light, if c is the speed of light in vacuum, you can write like this now. N1 is equal to c by v1 and N2 is equal to c by v2. Shall I write like that or not? Yes, because here N1 is the refractive index of the first medium and N2 is the refractive index of the second medium. N1 is the refractive index of the first medium and N2 is the refractive index of second medium. Then I can write like this, N1 is equal to c by v1. Similarly, N2 is equal to c by v2. Right. See this, N1 and N2 are refractive indices of medium 1 and medium 2 respectively. Okay, right. Next, so it is what? Next step, we can write equation 3 as, right? So equation 3 is what? This is equation 3, that is what? Sin I by sin r is equal to v1 by v2. Now we are going to write equation 3 in terms of refractive indices of two media, that is N1 and N2. Then you can write like this, that is what? N1 sin I is equal to N2 sin R. It is what? Snell's law of reflection, no? Snell's law of refraction, otherwise second law of refraction. So we know, already we discussed in our previous classes, what is the first law of refraction, what is the second law of refraction. So generally, what is the second law of refraction? The ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay. So from that second law of refraction, here N1 sin I is equal to N2 sin R. So this is as usual equation number 3, but equation number 3 we are writing in terms of refractive indices of both the media, that is medium 1 and medium 2, that is N1 and N2, right. See here. Next, further afterwards, after completion of this, further suppose if lambda 1 and lambda 2 denote wavelengths of light in medium 1 and medium 2, right, because light is entering from one medium to another medium, no. Suppose if lambda 1 and lambda 2 denote wavelengths of light in medium 1 and medium 2 respectively, and if the distance between if the distance BC between B and C, otherwise BC is equal to lambda 1, from our picture, and then distance AE will be equal to lambda 2, will be equal to lambda 2. Okay, then what will happen? Then what will happen? You can write the next step. What is the next step? This is lambda 1 by lambda 2 is equal to BC by AE, because we only decided just now. We only decided means not on our own, from the concept. From the concept, and light means wavelength. Light is traveling from one medium to another medium. Speed is going to differ. Okay, you know that C is equal to, right, nu lambda. C is equal to n lambda, or C is equal to nu lambda. Okay, anyhow that formula we will see in our future, no problem. But generally also here light is traveling from one medium to another medium. So wave is nothing but wavelength. It has some wavelength. Light wave having some wavelength is entering from one medium to another medium. So here BC is lambda 1 and lambda 2 is AE. So that you can write lambda 1 by lambda 2 is equal to BC by AE. BC by AE, right? So this BC by AE, you can also write V1 by V2. V1 by V2, right? So when you are writing this one like this, lambda 1 by lambda 2 is equal to BC by AE is equal to V1 by V2. Then you can write this one now. That is what? V1 by lambda 1 is equal to V1 by lambda 1 is equal to V2 by lambda 2. V1 by lambda 1 is equal to V2 by lambda 2. Okay. So this is the expression which gives the relationship between wavelengths of light in one medium and another medium to speed of light in one medium and another medium. Okay, right. So see the last point here. When a wave gets refracted into a denser medium, so generally V1 is less than V2, no? The wavelength and speed of propagation, the wavelength and speed of propagation decrease, but the frequency remains same. Frequency remains same, right? So keep in mind, when a light wave of certain wavelength enters from one medium to another medium, for example, from optically rarer medium to optically denser medium, then light ray bends towards the normal, so that the wavelength and speed of propagation will decrease. Why the speed of propagation will decrease? Because of decreasing wavelength, but frequency remains the same. So here we are getting a new point which is also important. When a light propagates from one medium to another medium, frequency of light is constant. Frequency of light is constant. That is also important point we have to keep in mind, right? Okay. So in this class, if you focus here, we discussed refraction of a plane wave. Refraction of a plane wave. And throughout this class, one important point I want to say, that is, according to corpuscular theory, whatever the prediction we got, it was proved wrong when compared to the prediction given by Huygens wave theory of light. What is that prediction? When light ray enters from optically rarer medium to the optically denser medium, light bends towards the normal. When light wave, here wave not ray. If I say ray, it is not in this chapter, it belongs to the previous chapter, because previous chapter is ray optics, this chapter is wave optics. So throughout this chapter, light propagates in the form of wave, right? So when light wave enters from optically rarer medium to the optically denser medium, it bends towards the normal. So speed of light will be decreased, wavelength of light will be decreased. So this is the information given by Huygens wave theory. So this information is available opposite according to corpuscular model of light. Okay, that is. So if you focus here in this class, what we did, right? So we drew a picture, right? we drew a picture here, that is what medium 1, medium 2 and P dash is the surface which separates both the medium. Afterwards, this is incident wavefront and this is refracted wavefront, right? So the wave is coming, the light is coming in this manner and here it is going to refract, so that we had here refracted wavefront, and V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2, and V1 into tau is the distance that is equal to BC. Similarly, V2 into tau is the distance that is equal to AE, and R is the angle of refraction and I is the angle of incidence. Okay, and this is all about when light wave is going to refract while traveling from one medium to another medium, that is optically rarer medium to optically denser medium. Okay, right. So after completion of this, we went to derive. So what we are going to derive? The relationship between speed and wavelength at the same time to check. So that is what, when a wave, light wave enters from one medium to another medium, how it bends, why it bends, right? So based on this picture, and then now if you go for derivation from two triangles ABC and AEC, we can write sin I is equal to BC by AC, that is equal to, as usual mathematically, then sin R, right? Now sin I by sin R, it is V1 by V2, it is like equation 3. Now you know these two things, that is N1 is equal to C by V1 and N2 is equal to C by V2. So if you write this equation 3 in terms of these two, then you can write N1 sin I is equal to N2 sin R, which is also, you can say, Snell's law of refraction. Afterwards, from the picture, you can write lambda 1 by lambda 2 is equal. From the picture means from the concept. Okay, lambda 1 by lambda 2 is equal to BC by AE, that is equal to V1 by V2. Finally, you can write the relation between speed of light in two mediums, right? In two media, that is what optically rarer medium and optically denser medium, that is V1 by lambda 1 is equal to V2 by lambda 2. So based on this our discussion and based on the formulas what we got from in our discussion, we can conclude that when a light wave gets refracted into a denser medium, from rarer medium, right, then the wavelength, or first wavelength only, wavelength decreases. When wavelength decreases, automatically speed of light also decreases, but the frequency remains same. Okay, so this is all about refraction of a plane wave. In our next class, we are going to discuss refraction at a rarer medium and reflection of a plane wave by a plane surface. Okay, thank you.